Hello everyone, welcome back to Advent Code 2024. It's time to start on day 2. And look, I'm catching up. I'm I'm doing this 12 hours after the problem released instead of 20. So, maybe one day we'll get to a live stream, which I did occasionally in previous years. But today we're just starting on part 2. Day 2, Red-Nosed Reports. Fortunately, the first location the historians want to search isn't a long wet walk from the chief historian's office. While the red-nosed reindeer nuclear fusion/fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. I remember this. This was in 2016, maybe? It was actually I didn't like that problem. Because, well, it doesn't matter. It's actually the one problem in all of Advent Code that I wrote Eric an angry letter about. I was like, come on, man, this isn't a good problem. It was a good problem. I just didn't like that the issue was the problem was posed as like the obvious approach was to search through a search space, and I don't think you really could have done it otherwise. And they asked you for the shortest path from a root node to some goal node. And so obviously if you do a depth first search of the search space, you might find a long path before you find a short path. And so, okay, you should do breadth first search. Or A star, but I guess you could do A star. But I don't know if you can know how far you are to goal node in that case. Anyway, it doesn't matter. Anyway, so I did breadth first search. And the problem was that the width, the branching factor of that tree was tremendous. It was quite large. And so I ended up like, you couldn't, I don't know, I ran out of space or something like that, or it got really slow. I don't remember the details. Shouldn't have gotten slow. I must have run out of heap to store all the states I could have been exploring. Whereas if you just did a depth first search using the same technique, you would find the answer pretty quickly. And I don't remember why. Like it seems like if the branching factor is large, depth first search shouldn't find the answer any better. So I don't know. Maybe that wasn't quite it. But it turned out, through some property of the problem that I don't remember and maybe never understood, that there could only be one path to the goal, and so searching in any order was fine. And so depth first happened to work if you didn't think about the fact that it might find you a long path before a short one. And that was what made me annoyed, was that someone who attempted to solve the problem correctly by making sure to find the shortest path first was presented with this obstacle, whereas someone who didn't know what was going on and did things in kind of the wrong way of depth first search was rewarded with an easy problem. So I said that to Eric, and he sent back an email that was like, yeah, I'm sorry you didn't like the problem. And I believe he also said, if you really thought about it, you could determine that there was only one possible, there was only one path to the solution regardless, and then you could do the depth first search. And I was never very satisfied with that, but whatever. Eric makes, I'm not mad. Eric makes lovely problems every year, but that's a problem that I remember, and it's funny that it was brought up here. Okay, continuing with reading the problem statement. They're quick to add that, since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. Your unusual data consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. Okay. This example data contains 6 reports, each containing 5 levels. Okay, so a row is a level, a column within a row, or a cell within a row, is a level. So a reading, I guess. The engineers are trying to figure out which reports are safe. And remember, a report is a row. No. Yes. Yes, okay. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing, and any two adjacent levels differ by at least 1 and at most 3. Okay. So the first one, yeah, they're safe because it decreases by 1, then by 2, then by 2, then by 1. This is unsafe because it goes up and then up by too much. This is unsafe because it goes down by too much. This is unsafe because it goes up and then down and then up. Okay. So, it seems as though we want to parse... I mean, you could just use a list of lists as your... input type. In fact, let's get over to the coding window here. Where am I? Okay, so let's get my input first. Good. Looks nice. Oh, they're not all the same size even. So you can't use an array or a two-dimensional array unless you use ragged arrays. You can't use a matrix if your language supports such a thing. Or a two-dimensional array, and yes, unless you do like an array of arrays. Okay, but that's not a problem for us. So we could just use a list of lists as our type. But one thing that I like doing in general, I feel it's its own reward, and also like in Advent of Code, it's an excuse to practice it, is domain modeling. So they have names for these things in the problem, right? They have levels and they have reports. Let's name those concepts. Let's say I think I will just use a type. This is a thing you have a decision in Haskell when giving a name to an existing thing. Should you just use a type alias like type level equals int? Or should we say new type level is a level int? These are two ways to define a type named level that is basically just an int. You could also, if you really wanted to, you could define data level equals level int. But I think we all agree that this is not really the best answer. It's the most heavyweight, and there's no particular reason for it. So the idea is, with type, Haskell will treat the types level and int interchangeably. If I say my function takes a level and returns a level, I can just say add 1. And it says, oh yeah, okay, well, since the level's really an int, you can just add 1 to it. With new type, the compiler sees them as different types. You have to explicitly wrap or unwrap levels anytime you want to deal with the int inside. This is useful for a couple of reasons. One, it lets you define new type class operations. Like, let's say int has a show instance, which it does. You can print ints. Let's say for some reason you wanted a different show instance for levels. You couldn't do that if you used just a type alias like this. You could if you used a new type. Let's ignore the fact that show is maybe not the best example, but type classes in general. It also, if there's some danger of you getting a level int mixed up with some other kind of int, using the new type makes sure that you have to actually mention the type when you're working with it, so you don't get confused with integers representing meters versus integers representing degrees Celsius or something. You can give them each a different new type. That would be much safer than just using a type there. Here, for this problem, I think a type is fine. And we'll say that a type record is just a list of level. And then our input is a list of record. Isn't that nice? We have this little hierarchical structure here. To be clear, by the way, both new types and types cost nothing at runtime. They're free. You have to be a little careful with new types because you might... Anyway, it doesn't matter. If you like to convert a level to an int, if it were a new type, is free. But converting like a list of level to a list of int, if you just call like a map convert over the whole thing, you could end up paying the cost for map. And there are ways to avoid that with coerce. But so they are free as long as you're careful. Whereas type aliases are always free because they're just different names for the same type. So an int is a level, a list of level is a record, and a list of record is our input. To parse, I think is pretty simple. We want to say this? Is that right? We split the input into lines. And then over each line, we map a function. That function is to call words, splitting it into the space delimited things, and then call map read on the result. I think that makes sense. So let's does that make, yeah, that all compiles. Great. So fine. That's all the input processing done. So they're asking me how many reports are safe. So it seems as though we could write part 1 pretty simply, although glossing over one part that will be a little bit more complicated, as length filter safe, right? Where safe is, something. That's a very clear just restatement of exactly the problem statement. How many of the records in the input are safe? Now, we want to take the deltas of each record, of the levels within a record, right? And so there's a cute trick. I don't know, deltas, I guess. Or you could say, we call this function pairs. We would take I'm not going to use this function, but for example, a list of A's, and it produces a list of pairs of A's. And pairs is just zip with tail. So this gives you, actually so it says there's a hole here. Did the rest of the, it didn't, right? Yeah. Can I there's something, I don't know if this is exactly it. Language deferred type errors or something? Is that a thing? No, it doesn't exist. But there's there's some way to defer. GHC defer typed hull errors to runtime, so you can run, deferring type. The GHC GitLab keeps giving me a 502, which I don't really appreciate. I can't browse a bunch of documentation. Typed holes always appear as errors even when deferred. Okay, that's interesting. F defer typed holes. Is that... So I found there's a GHC option called defer typed holes. I don't know if that's the same, if there happens to be a corresponding language option. There isn't. Okay, so I don't know how to do this. Whatever. We just won't use... We'll do it like this instead. And then I can say, what are the pairs of 1 to 5? And there you go. We get 1, 2, 2, 3, 3, 4, 4, 5. So the idea here is this little operator here is, you know, the applicative combination operator. You could call it app. And when applied to functions, it's the same as this. So zip x's with the tail of x's. Cute trick. We don't want pairs. What we want is, oops, not here. Zip with minus tails. Tail. So zip the list with its own tail, and subtract. So this is a function that, given a list of ints, tells you the deltas of that list. And then we just have to call that function and confirm that it's behaving in a way that we want. So you could like say, oh, let's get the deltas, and then say, are they all the same sign? And are they all with magnitude 2 or less? It seems like there's a better way to do that than just calling two functions. I don't know. Although, I mean, actually, it's kind of nice to write it that way, isn't it? Safe is lift a2 of and of same sign and what do they call it? Gradual. There we go. So we could say composed with deltas. So lift a2 of and is basically, again, like applying the applicative, or it's using the applicative instance of functions. And what we're going to get out of this is a function that takes as input some value, calls same sign on that value, and calls gradual on that same value, and then combines the results by calling and on them. That's exactly what we want when we want to combine. We want to assert that two different conditions are both true of the deltas. So then we can just write same sign and gradual as well. Same sign is... Now there's not actually a great like built-in function in Haskell for is this list of things all the same? Actually, you know what? Let's why can't I type? There we go. All small. And we'll just write small. Actually, let's write that before same sign. It's kind of fun. Small is going to be the same idea. We'll lift a2. I mean, I don't know. We could just say it's greater than. Well, maybe I will. Small x is greater than. No. Small. We'll do the same little trick here. Lift a2 and of greater than or equal to 1 and less than or equal to 3, composed with the absolute value. So is the number's absolute value between 1 and 3 is what small is saying. All small is saying, look at the whole list. Are they all that way? I might have to import all. I don't know. And same sign is... let's just destructure the list here now. Pattern match, get the first one out. All equal abs x of map abs x's? No, not map, not abs. Signum? What do they call the thing in Noom? Okay, there it is. Yes, signum. So, do the numbers beyond the first all have the same sign as the first one? This is technically an unsafe function because it doesn't handle the empty list. So we'll put that in, even though I assume the input will not be empty. Just as sort of good practice. We are using another unsafe function somewhere in this file, and we usually will be for Advent of Code, for what it's worth. In case you haven't spotted it, you can look around if you want. It's read, of course. Read isn't safe. It just blows up if the input is not parsable to the type that it's looking for. So, I don't know. Always be... If you have that in your production code, you should be careful. Here, we're not going to be careful. This isn't the file I wanted, actually. I want this window. It compiles. Okay, that's good news. Does it run? Yeah, it's a number. Amazing. 202. Is that plausible? If we look at our input, there are 1,000 reports. Yeah, it's very plausible that about a fifth of them would be safe. We are asking how many are safe here. How many reports are safe? It does feel like I could just enter the answer, obviously. It does feel as though I should do a little bit more due diligence on this. By, at least testing part 1 on something. So let's try that. Part 1 on 1, 2, 3. That should say 1. 5, this should still say 1. 6, this should say 0. Nope. Problems. Oh, I forgot, of course. Good, I'm glad I tested that. Differ by at most... Oh, no, this is fine. Differ by at most 3. So, right, differing by 3 is allowed. Okay. So if I do this, this is differing by 4. It should be marked unsafe. Yeah, it is unsafe. Okay, I mean, it seems pretty good. And then -1 to 0, this should be unsafe because it's, yeah, this looks good to me. So 202. That's the right answer. Great. So let's commit that. Yeah, commit that. Oh, hang on, you guys aren't looking at this window. I'm just doing a git commit here. Nothing interesting happening. Commit that, commit that, commit that. Sure, include this new line thing. I don't know why there's a carriage return at the end of all my input files. Or a... What's the one that's D? Is that a carriage return or a new line? It's a new line. No, it's a carriage return. I don't know. Anyway, I think there's a carriage return at the end of all my files for some reason. I'm sure I messed up the template a couple years ago, and I've just been reusing the same stupid template, but... I'll suffer through it. And, what I should do is just, write a tiny little script that strips the new line from all of them, but it's too hard. I'm here to have fun, not to have a perfectly clean git commit history. Although maintaining a clean git commit history is part of what I find fun, but not this part of it. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Single bad level. Oh, this is okay. This is cute. So you could modify, well, yeah, I mean, I guess you could try to do some cool surgery where you like you see whether a level is a report is unsafe, and if so, you like see why it's unsafe and look at the things around it and see like, oh, could I remove this and make, but like really it's just going to be much simpler if I just say, here are all of the ways you could modify this report. Are any of them safe? Right? And that will be pretty simple. We have a few things to... I mean, pretty much all of this we're going to want to lift up to the top level. Because it turns out we need it for part 2 as well. Oh, these are actually all lined up correctly. Okay. So safe is a function from report to bool. Yes. Not report. Record. Did I use the wrong name for this whole stupid thing? Oh my god, I called it a record. It's supposed to be a report. Okay, I'll fix that afterward, I guess. A record. So this still, let's just confirm, still gives us the same answer. Great. This returns an int as well, and its length filter can be made safe. Can be made safe. X's, I guess. I'll call it R for report. Or record, I guess. Is any... Well, actually, we don't really need to name the report here, do we? Any safe composed with... What do you call a function that returns all the ways you could remove at most one element from a list? Remove. What do they call it in the problem statement? The problem dampener. There you go. Dampen problems. Easy. Dampen problems of x's is going to return a list of all the ways you could remove up to one element from x's. So it's just x's cons to remove one x's and remove one of this is nothing. Does this make sense? Hang on. Am I bad? No, that's fine. Yeah. There are 0 ways to remove... No, this isn't quite right. I want... Okay, well, so the funny thing is, it's actually easier to do this, at least for me, it's easier to think about it as the general case of remove exactly, or remove up to, I guess, remove up to n elements and then specialize that to 1 than it is to do the one case to begin with for some reason. So I'll write that, because I've written that many times. For some reason, this idea of removing just 1 is confusing. So let's say this is do. Remove up to 1. Actually, why this dampened problems doesn't need to exist anymore, does it? Remove up to 0 of an input list is, there's exactly 1 way to do it, which is the list itself. Remove up to n x's is, first, it's x's, you could not, oh, hang on. Remove up to n. Do I need to pattern match here? I probably should. X's. Yeah. So we can either leave x in, so first call remove up to n from x's, the tail, and cons x onto all of those. So we haven't removed x, but then we add that together to, let's try remove up to n minus 1 of just x's. We don't add the x back in. So this, I don't know why this seems easier to me than like handling the 1 case specially. We do, I think, need a special, I mean, we might end up with some duplicates if I'm not careful here. Remove up to, I guess, no, it's fine. If we're left with an empty list and we are allowed to remove up to n elements, I guess it's fine to just still... Oh, but I do need to handle it, don't I? Yeah. So to remove a non-zero number, is also x's, right? So if you get to the end and you haven't removed anything, that's allowed too. There is one way to do that, which is to not remove anything at all. Defaulting a type variable to integer. Because I used an int and I didn't tell you what signature I wanted, I guess. I mean, obviously it's fine to leave that in, but I guess I can give this a type. It's no problem. Happy? Great. 271. It's larger. The problem statement led me to believe that lots more of them would be larger. Well, I guess we can do some more testing, right? So what if I said part 2 of this? That should all be fine, because you could remove the 7 and you could remove the 0 or the 2, right? Yeah, so those are all okay. But if I then add a 1 here, hang on, that shouldn't be safe, should it? What could you remove from that last list to make it safe? If you removed the -1, then it would be decreasing and then increasing. That's not allowed. If you remove the 2, yes, if you remove the 2, it's safe because it goes down by 1 each time. I see. So if I then add another 0, now it's really unsafe. Okay, I mean, on some simple testing, it seems like this might work. Let's put 271 in there and see what it says. That's the right answer. Okay, I'll take it. And it seems like a pretty self-describing solution, right? You say, the number that can be made safe, can be made safe is remove up to 1, and are any of those safe? And remove up to is, okay, a little bit arcane, the implementation, if you're not used to seeing code like this, but at least the name itself describes what it does. I'll take it. Yeah, that looks fine. Day 2, part 2. And before we go, how do I do this? Replace record with report. Day 2, they're called reports, not records. So, I didn't add. What? What's going on? Change is not staged for commit. It's true. I didn't add. Okay, there we go. So the other thing I want to do briefly here is, of course. If I say git rebase, if I rebase this on top of origin main, can I make it look like I was always doing this correctly? If I just say squash that in there, does that apply cleanly? No. Okay. Let's take a look real quick. Is it a clean merge to fix? What? I'm so bad at merges. I used to be okay at them, but merging in a rebase is very confusing. All right, so we just won't do this. Okay. Now we're back to, great. Time has not been wound back after all. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.